Can everybody hear me first of all? Okay. What I'd like to do just to start off is just to have a very quick talk about the FunCube dongle, because I'm assuming, does anybody not know what the FunCube dongle is? Okay. I was not heard of it, shall I say. I just want to really reiterate some of the key reasons why we did the FunCube dongle, because a lot of the people who have purchased the FunCube dongle, they want it to do everything, and that's great. But we really do need to make sure that we remember that this is actually for the FunCube satellite and for the use of both amateurs and non-amateurs. So let's just reiterate the sole aims of the FunCube dongle. It's the ground station receiver for the FunCube satellite, which I'm sure you'll hear some more information about over the weekend, which is due for launch soon now. And with that in mind, we had some primary design requirements, and you may have seen this slide before, and it doesn't change. This still remains the same. It's accessible, so it's in a nice form factor, and it's for both amateur and non-amateur users. And we wanted to minimise the amount of setup, so we didn't want to have tons of spaghetti hanging out of the back of a machine. We wanted it to be as plug-in as possible to go, and I think from a hardware perspective that's possibly the case. And we wanted to keep the cost low as well. So let me just tell you what the state of the FunCube dongle is, because there's been quite a bit of speculation about it. Until mid-July, the FunCube dongle was still selling well. In fact, I'll tell you right now, I assumed around about July, August of last year, so that's over 12 months ago, that the FunCube dongle, it had been on sale for already about 7 or 8 months, and I assumed that it was going to start slowing down on sales, and I'd actually taken about 6 months off from work so that I could get the FunCube dongle into a state where we were selling enough, or we could actually manufacture enough, because for the first 8 months we couldn't actually keep up with demand. And the first sort of couple of iterations, I was making a batch of 100 at a time. Well, they sold out, as you probably well know, in a minute or so each time. And so we thought, well, we need to do something about this. So we upped it to 500 units, and still we were selling out before each batch. We couldn't keep up with the demand. So I went back to work assuming that the demand was going to fall. So I was doing a 9-to-5 job, and unfortunately the demand didn't fall. And so my day for about a year was to wake up at 6 in the morning when my FedEx guy turned up every day and deliver do the international deliveries. And then I go into work, and I come back about 5 o'clock, and then I prepare for the next day's deliveries, make up the dongles, test them, and that was every day. And it wasn't just 5 days a week; it was also 7 days a week, because during the Saturday and Sunday that was drilling the holes. So at the bottom of the dongle, where the antenna socket comes in, I'm so cheap that what I could do is I could have the moulding made with the hole already there for the antenna socket, but that was going to cost an extra $1 an enclosure. And I thought, well, how quickly can I drill a hole? So I do about 500 at a time, and I can drill 500 holes in 90 minutes. So I figured that's actually not a bad pay rate. So I still drill the holes myself. I still put the labels on, make the labels and put the labels on myself. Again, I'm too cheap. And some of you have some of the very early dongles. You'll notice the labels are a little bit wonky. And I hope my YL isn't listening to this, because she's, bless her, she's very good, but she won't accept the fact that you really do need a magnifying glass when you put in those labels on, because they look a little bit wonky. So if you've got a wonky one, that was my YL that put those labels on. Okay, so what happened in mid-July? Well, we exhausted the supply of the tuner chip that we were using. Now, we had been made aware, in fact, by a customer of mine that who happened to work in exactly the same building as the designers of the tuner chip that we used inside the original FunCube dongle, that they'd gone, that they'd closed for business. Literally, it was in the afternoon it happened, and there were signs apparently put up on the doors, and I received this email, and it said, Howard, need to contact me very quickly. So I did, and he told me what had happened. So immediately I put an order in for, just in case it wasn't true, for a couple of thousand extra tuna chips. And sadly, I was too late. And the organisation had already gone into receivership and more latterly liquidation. And so we haven't been able to source any tuna chips at all since around about, I think it was March time. But we managed to have it, we had enough stock to last us until mid-July. Now, pretty much as soon as this happened, I started phoning around because I happened to know where the chips were assembled. The actual tuna chip guys, the E4000 tuna chip, is made by a company called Elonix up in Scotland, and they use a manufacturing plant in Wales to actually assemble and test the chips. And so I got on the phone to them and said, have you got any? And they said, yes, we've got 45,000. And sure enough, they have 45,000 chips assembled, tested, ready to go, sitting in a warehouse, plus another 250,000 sitting on wafers. So we're not short of chips. However, at the moment, the liquidator is in the process of trying to sell off the intellectual property assets of Elonix. And they have been very, very difficult to engage in trying to release any of these devices as a result. Over a beer, I will tell you exactly what I think about these liquidators. But it's at times like this I wonder if the liquidators really are working on behalf of the client and not on their own account. But anyway, so I actually I put in a cash offer, which they spent about weeks and weeks umming and ahhing about, and then said no. And I said, okay, tell me how much you want. And then they said, we're not selling. We're going to have to wait until the IP asset sale is over. That's still going on. They're delayed for another month. I did actually get an offer of 1,000 parts from a third party about 6 weeks ago, but the price wasn't right. Didn't really make a production run viable. I was hoping, on the basis that the offer came in from Taiwan, that he was going to turn around to me and say, he came up with a certain price, and I said, no, not at that price. And I expected him to come back and say, all right, how about this price? And he didn't, so that was a bit of a shame. But by that time, things had moved on rather. So I'm pretty certain that that tuna chip will become available. At the very least, the assembling plant up in Wales has got a huge amount of stock there, which currently they haven't been paid for. I'm sure they'd be delighted to have funds. I've also explained to the liquidator in very plain terms that, in fact, the longer you wait to provide these chips, the more people are going to have done redesigns, and you've lost the market. However, it did fall on deaf ears, I'm afraid. So what were the next steps? Well, we have this satellite launch very soon, but we don't have any means of individuals being able to receive the satellite. So we decided to develop a replacement FunCube dongle or SCD. And we could have just redesigned it and just produced the same thing again, which would have been the easy thing to do, except none of these tuna chips are the same. They're all based on proprietary technologies. They all have different pinouts, different requirements. So it was pretty much going to be quite a bit of redesign anyway. But also I thought, well, why don't we take the opportunity to add some more, improve the performance of it, particularly things like the pre-selection. That seems to be a big thing that it causes, there's a lot of requirements for that, particularly at VHF, and possibly see if we can add some more features. So this is mid-June 2012. We made the decision to build a new SCD and started a parts evaluation. This is the new logo, by the way. It's actually up there as well. 2012, we chose the principal parts. That's things like the new tuna chip, or made a punt at a tuna chip. until you put these things together, you just have no idea whether they're going to work or not, or how well they're going to work. So I had a couple of tuner chips I was evaluating. I did some really extensive unit testing, which I'll talk about a little bit later. Breadboarded a prototype. Actually, I breadboarded 2 prototypes. August 2012, last month, did more unit testing, did 2 PCB spins, and the final design was accomplished at about, I think it was 31st of October at about 11 PM at night. And then I had a very large gin and tonic. September 2012, I've ordered the first production run. That's due in, I guess, beginning of October, and the online shop has been developed. I say pre-ordering now taken. It will be taken when I just press this button here. This is not going to work now, is it, after all this? Just thinking about it. Oh, okay. Hopefully on the front page of the Funcube dongle page you will now be able to do a wait list. It probably hasn't worked, so I don't know, but we'll see. It's a bit slow on this. This is I should also add here, this is a product release. And I'm also hoping that what I'm going to tell you, what the benefits are, and the enhancements, the features, etc. I'm hoping it's going to be better than the iPhone 5 release was. As with any Apple engagement with marketing, feel free to go whoop or woohoo or yeah when I come to the features. If you don't want to do it and you feel slightly embarrassed about it, don't worry. Is it on there? On the front page now? It isn't. I've got to do... Perhaps if I press publish. Technology. Anyway, it doesn't matter. It doesn't work. It doesn't work. Is it there now? There should be a... Yeah, okay, so you can now put your... It's not technically a pre-order, it's put you on the wait list, so you'll receive an email saying that if you do wish to go ahead with it, this is where to go to do so. But you can put all your email details there and be ahead of the game. October, okay, we still have to go through the CE and FCC certification. That's scheduled for the first week in October as well, so hopefully when the first production units come off the line, the CE certification will be fine, and I won't have to do any rework, but we'll see. And the first units will be available in October, all being well. So that's the schedule. Then talk a little bit about the performance improvements, and also I do have the only one in existence right now. I was going to have a few more, was always my intention for looking at, but unfortunately I've spent the last 2 weeks organising the wait list on the Funcube Dongle Pro Shop. Believe me, e-commerce is not as easy as it should be. So if you'd like to have a look at this is chock full of electronics. So it is the only one, so I'd like it back if that's all right. So the performance improvements. Improved dynamic range. The new device that we're using on there is it's a 3.3 volt tuner section instead of a 1.5 volt tuner section, so immediately we get a bit of benefit there for dynamic range. The LNA is an improved device. It's an Avago device. It's got a 30 30 dBm OIP. It might even be more than that. I haven't actually measured it. The spec sheet says about 35 dBm, but I'm not running it at the full current and voltage. And a better tuner and ADC noise floor, which was great, because that's the problem. You don't know with these devices until you actually put them in a circuit as to how they're actually going to behave. But the noise floor seems to be around about 7 or 8 dB lower than it was before on the ADC input. So excellent frequency stability and accuracy. you may remember certainly the first 800 or so serial numbers below about 810. I used a cheap crystal, which although it was cheap, it did mean that if you sort of held the device, it would change in frequency a little bit. We're using a 0.5 part per million temperature compensated oscillator on there, which is great because when I used to test these devices, every single time I tested the sensitivity for them, I used to have to do a small adjustment on the frequency just to make sure I got it in place. Right now, I can just plug them straight in, and they're always dead on frequency. Internally, we use a 24-bit ADC depth. In fact, it's actually 32-bit, but there's little reason to go beyond about 20, to be honest. There's noise beyond about 20 bits. That's internally on the device. Also, we have 11 front-end hardware filters. So those are discrete filters, either made up of inductors and capacitors, or they're SAW filters. They're pretty serious, these SAW filters. I actually have the plots up here on the right. The top one is the 2-meter filter. That's showing a 6 megahertz wide filter response there at 3 dB down. And certainly for the UK people here who suffer from pager interference, that's 45, 50 dB down on the area of interest. So I think that's down about 138 megahertz and up at 152 megahertz where we have pagers here. That's about 50 dB down off of the frequencies of interest. On the bottom there is the 435 megahertz filter response. I think that has a width of around about 20 megahertz, something like that, centered on 435. So you see quite serious filters. I spent an awful lot of time around about a year and a half ago, and David will remember this, David Bowman, looking at this, and we were looking at using all sorts of, I was looking at using all sorts of things. David already knew what the answer was. I just had to prove to myself that he was right. And lots of time trying to build filters out of discrete inductors and capacitors, and also winding my own coils, and doesn't seem to be any way that you could get a really good narrow filter using inductors and capacitors, just lump ones. You could get quite narrow if you started to use wind your own coils with thick wire, but the problem with those was that you needed to massage them manually yourself to get the required limited bandwidth out of the filter. And the last thing I wanted to do was to have to spend a significant amount of time tuning every single unit, and potentially, if those coils get bent a little bit out of shape, out in the field, so to speak, it would completely ruin the performance. So we went to SAW filters, which is what David always recommended all along. I think even over 2 years ago we were talking about SAW filters. And sure enough, that's what we've gone to. The reason I didn't use SAW filters at the beginning was they are very expensive. It's the SAW filter that I have in the 2-meter SAW filter I have in there actually costs twice. It's the most expensive part. It's twice as expensive as any other part in the whole unit. So that was a reason for me to push against doing that, because obviously price sensitivity on these things is quite important. Also, the LO noise seems to be much improved from the original version, in that's the little peak that you see in the middle of the passband. It's still there, but it's much lower than on the previous unit. Okay, functionality improvements. Increased the bandwidth to 192 kilohertz. So you have twice the width of band to be able to see simultaneously. Tuner PLL steps, less than half a hertz. So the PLL in there is quite juicy. What's the frequency coverage? Okay, so as with the L1, we have 4 meters, 2 meters, 1.25 meters if you're in the US and Canada, 70 sems, 33 sems if you're in the US and Canada, 13 sems. We cover the whole of the 13 sems band now. We don't miss out anything. 6 meters, 160 meters to 10 meters. Woo! LF and MF. In fact, this is the range of it. It's 150 kilohertz. It's probably a little bit less than 150 kilohertz. Up to, well, I'm going to state 240 megahertz. I haven't characterized the devices yet. They do seem to go up to 250, but I'm going to say 240. 420 megahertz up to 1.9 gigahertz. Again, I haven't characterized the devices yet to really say definitely it's 2 gigahertz. The ones that I've played with so far, yes.
Is that 23 sems, not 13 sems?
Sorry, it should say 23 sems. Sorry, I lied. I do apologise. That'll teach me, won't it? That should say 23 sems. 23 sems, sorry. Funcube Dongle Pro Plus. This is the board layout. You probably can't see it from right in the back there. 6 layers. That was interesting. That took me about 2 weeks to do. You don't know until you've laid out all of the parts that you're really ever going to be able to fit them all on. Paid an awful lot of attention to the actual parts that we used on there. Whether the inductors in particular, we were going to use wire-wound inductors or multi-layer, and particularly worried about the Q on those and the size. So it's a big engineering thing where there's lots of conflicting requirements. You know, you want a small device, but you want a high Q. Doesn't always work like that. So that was quite interesting trying to get all that done. 2 full breadboard prototypes were built before I went to doing a PCB. There's now 240 discrete parts on there compared to only 100 on the old unit. There are parts on the top and the bottom of the board, as you'll see. There's not a huge amount of room left for much more if you've had a look at that board. It's a 6-layer board, as I mentioned. This is the layout, and I'm really sorry for the ATV guys because you're probably not going to be able to get the resolution right on that. This is the block diagram. We'll keep the bias T on there. Have we got a pointer? No. Okay. Right. I'm going to move over here then. These are all the filters that I mentioned. The 11 filters on the pre-selection filters. This is the HF path. Sorry. That goes to 4 pre-selection filters. There's also the 32 megahertz up to 75 megahertz also goes through here as well, after the tuner chip. Tuner chip is different from the older Lonix one because there are 5 separate band inputs, RF inputs, whereas the E4000 chip only had a single RF input. So it's a little bit different the way that you deal with this. Oh, you got one, have you? How do I do it? Oh, here we go. That's it. Yeah, sorry. So these are the 4 HF front-end filters. This is a filter for 6 meters and 4 meters. You'll see here the VHF path here. That goes, it's a first of all high-pass filter, then the LNA. The high-pass filter, by the way, been very, very careful on the parts that we've used for that, using wire-wound inductors, and not the smallest ones either, because although much as I love the 0402 size, there's some 0603s on there to really get the Q up there and minimise the losses, so that we have the sensitivity of the Funcube dongle is absolutely sweet at 6 meters. Haven't measured it, but it's actually I get about 15 dB synad at 150 microvolts. So I used to measure for 150 nanovolts. That's right. I used to try to get 12 dB synad at 0.15 microvolts. And at 6 meters, I'm getting another 3 dB on the synad there, which is quite nice. So also for VHF and above, we've got 6 different filters here. We've got some wider filters covering the band 2 broadcast band, 75 to 125 megahertz. For the 125 to 250 here, there's a bandpass filter. This one again has been highly tailored to try to null out the band 2 VHF. So that this is quite there's a lot of parts in, there's lots of L's and C's in here to minimise the desensitivity coming from band 2. There's this super duper SAW filter, which is the biggest part on that board, which you can see going round. Similarly, on the UHF band, I've got a bandpass filter here, which just covers the whole of the UHF band plus the 435 megahertz SAW filter. And then we've got the L band filter here, 875 megahertz to 2 gigahertz here. Tuner chip. New codec chip we're using now. That was interesting to fiddle around with that. It covers 192 kilohertz, but the internal filters on the codec actually, because it's designed for audio functionality, cuts out at about 22 kilohertz if you follow the instructions it says on the manual. If you fiddle around with the filter settings a little bit, you can make it use get the full 192 kilohertz bandwidth out of it, but you need to do a little bit of jiggery pokery, which took quite a bit of time to make it massage it to do what I want it to do. I've upgraded the PIC. I'm pressing the wrong button here. Oh, there we go. I've upgraded the PIC. We're using a PIC 32 now. That's better for the 192 kilohertz, but probably more importantly, the PIC 32 for some reason is slightly cheaper than the PIC 24s now. So go figure. You see up here there's a 0.5 part per million TCXO. Another little thing that I've added in here is I've added a calibration signal generator in there. So it's possible for the unit to actually test itself. One of the problems I had is with all these discrete filters for testing during assembly, I didn't want to have to go through but at the moment for testing, I haven't written the software for the firmware for the calibration testing yet. It takes me about 2 hours to test the whole unit through end to end. I really don't want to have to do that with every single unit. So put this calibration signal generator in there, which is just it's a Scilab's clock generator, which I use on there, which happened to have some spare output, so I used it for the calibration. And it goes up to about 150 megahertz, and then I use the harmonics for the higher frequencies to calibrate. Now that could also be used for calibrating the I and Q imbalance, although I've noticed that this tuner chip seems to have better I and Q balance than the old Elonix chip. Okay, sorry Ursula, I said I wasn't going to go into the technology too much this morning, but so these are some pictures that I have of the unit. This is the back of the old FunCube dongle. This is the back of the new one, so you can see it's full of parts. Similarly, that's the old FunCube dongle. This is the new one. If you've ever seen the old FunCube dongle inside, and now you're looking at the new one that's going around now, there's clearly a lot more parts on there, and it's still manufactured in the UK. Woo! Continues to help fund the FunCube satellite, so thank you everybody for purchasing the FunCube dongle, because there's obviously that goes into investing into the actual satellite itself. And what's the pricing for your DC to daylight FunCube dongle Pro Plus? Okay, going to make no excuses. The parts on here, 240 parts compared to 100 parts, it's a lot more parts. Not only that, there's an assembly cost increase. However, we did really try to keep the costs down to something that was realistic. So we're £25 more than the old one, which equates to $199 US, and that's the other pricing for you. So thank you very much for your time. That's a new FunCube dongle Pro Plus introduction, and if anyone's got any questions, I'll be happy to answer them.
Kick off, there's 2 questions from the questions and answer them.
Yeah, there are two questions there. Clearly, these are radio amateurs who love to reverse engineer things. The SAW filters, I haven't made any. I'm really bogged down in just trying to get this product out at the moment, and I don't really have any bandwidth to start selling discrete SAW filters, I'm afraid, at the moment. That might change. Just to give you some indication, by the way, I ordered 2,000 of these things, so if nobody buys a FunCube Dongle Pro, I will have a lot of SAW filters. The same applies to the tuner chip. We did not want to get into the same pickle that we did with the E4000, and took some time doing due diligence on the manufacture of this new tuner chip that happens to have Plessy investment, among others, and but also just to really make sure I have an order for 5,000 of those chips. So, as I hope you can understand, this is not an insignificant investment that we're putting up front here to make this thing work. So, again, unfortunately, there is an NDA attached to the tuner chip. These guys are really only interested in selling. To sell 5,000 is probably their smallest order that they've had for a long time.
Okay, thanks, Howard. Two more reasonable questions, I think. What voltages are available by the BATC? Why is there a coverage gap at 1.3, and does it require any software drivers? And VK6 KCH says, well done, Howard.
Oh, thanks. I remember the last question. That was all right.
BATC drivers, and is there a gap at 1.1?
BATC is the same. It's about the only thing that is the same as the old FunCube dongle. Everything else is completely new. The BATC is still 5 volts. It uses the same parts. I didn't change any of that. So 5 volts is the answer on the BATC. It still has the same PTC fuse in there, so it cuts out at about 160 milliamps or something to protect the device. Sorry, what was the next question?
Drivers?
Oh, software drivers, yeah. There are no, again, keeping in mind with the previous FunCube dongle, absolutely, there are no drivers required for this other than the ones that come with your operating system. That was another sort of key thing to try to keep the installation easy. That, in fact, it was quite interesting because I didn't think 192 kilohertz was possible. If you read on the internet and people talk about running 192 kilohertz sampling rate on an audio device on a USB 1.1 compatible device, everybody says no, you can't do it. Actually, that's not true. You can do it. There is sufficient bandwidth. You just can't do it in full duplex. Well, we're a receiver only, so there is sufficient bandwidth to do that. It's within specification. And it does work straight out of the box. Now, I mentioned earlier on about the 24-bit ADC sampling. There's an interesting feature of Windows, of course. If you have a device which supports both 24-bit and 16-bit, it will always choose the 24-bit ahead of the 16-bit. Now, unfortunately, there's not enough bandwidth to provide 24-bit 192 kilohertz sampling, but there is enough to do 24-bit depth, 192 kilohertz or whatever. Anyway, whatever. So I'm still fiddling with the drive. It may be that we have to have two different firmware. One for Windows, one to support the 24-bit depth, and one to support 16-bit depth. But that's something I'm working on. It will support them both. It's just not at the same time at the moment. Okay, what was the next? Oh, there was a question about why is there a gap at 1.3 gigahertz? Pro Plus doesn't have that gap. Thank you. Yeah.
It has another gap.
Yeah, the other gap is between 240 and 420, I think. Any more questions?
Availability?
I had a question about the availability. Oh, did I not put it on there? Sorry about that. I meant to put that on there. Mid-October. Assuming all the conformance testing goes all right, and there's no problem at the manufacturers. I mean, I've ordered 1,000 assembly run of 1,000 for the first batch from the manufacturers. Might be a bit brave, but especially as the conformance testing hasn't been done yet. But we'll see. Sorry, Graham. You had a question?
Yeah, thanks, Howard. Compatibility with existing SDR software?
Yes, absolutely. Again, as with the original FunCube dongle, and also with the driver thing, these are fundamental things that we wanted to do. We didn't want to have driver hell where everybody was searching around for the latest driver, spent hours trying to support that. So this runs straight out of the box with things like SDR Sharp, SpectraView. In fact, SpectraView doesn't support 192 kilohertz on audio stream. It will do on SDR-IQ, but it's not from a sound card. So I use SDR Sharp for my 100. And it's absolutely beautiful, crystal clear FM. It's lovely. The other thing is, actually, I've quite enjoyed playing with it because I never realised how many stations there are on long wave until I started playing with this little thing. Anyway, sorry. Next question, Ken.
Yeah, sorry, Howard. Availability, you've mentioned. Okay, apart from your website, is it also going to be via a well-known UK amateur radio supplier, or will the priority be the website orders?
Yeah, I've been, as you can imagine, Martin Lynch has been very, very kind to AMSAT for a number of years, and he also runs a bricks and mortar and internet shop, and he's our sole European distributor, and he will be selling the FunCube dongle. And in fact, the reason why I've set up pre-ordering is because I'm well aware that Martin can do pre-ordering as well, so I didn't want to be left out without me selling any, so that's why I set up the pre-ordering. Any more questions?
The various filters, are these automatically selected, or are they selected by software?
Yeah, they're automatically selected, although the firmware the front-end software on that, you can change the default if you want to. Hopefully I've calculated it right, that it does actually select the right filter for the right job, but you can override that if you want to. Any more?
So there's a question from G3RWL. If the liquidators come back to you now saying you can buy the old tuner chips, what will you tell them? Brackets, politely?
Yeah, I mean, it's not definite that we're not going to make any of the previous FunCube dongles. We may yet still do that. But of course the market is probably somewhat diminished now. I got it back. Because of the new FunCube Dongle Pro Plus. So it might be that we make some more, but it'll have to be at the right price. I mean, bear in mind that I have enough boards already to make another batch of 500. I've probably got enough parts pretty much to make another batch of 500 or very close to. I've got tons of crystals, all sorts of stuff to make loads more of these, because as you imagine, when you get the ball rolling on these production runs, you tend to order a few more than you really need, and that goes for everything. And so I have boxes and boxes of parts which could be used for another production run if necessary, and we could probably do it at a reduced price because of that. But there's no certainty on it. But if they came back to me with a reasonable price, I might do that. But at the moment, there's nothing. Sorry, Mark. I've been told to wind up. We can do a quick one more. Yeah.
Just a quick question. Any comments about the educational version that we've heard about?
Yeah, the educational version, the same applies to this one as well as the original FunCube dongle. Is that we'll provide this in a restricted coverage version. It's a bit easier to do with this device because we just don't put half the parts on the board. The previous one, there wasn't really any way of restricting it beyond changing the firmware. On this one, we can just leave out most of the parts. And you've got an educational version. So, well, unless you want to spend hours putting parts in yourself. You know, yeah. Any more? Okay. Thank you very much.